So in question 7, we are given this differential equation, and we need to solve it with these initial conditions, with these boundary conditions. So what we can do here is either use the integrating factor method, but perhaps the easier method is to simply first look at the homogeneous part of the equation. So just when we only have y's in the equation, so we just remove the x for a moment. So we have the homogeneous part, so y prime is equal to y. Well, we know that a solution to this is y is equal to a times e to the x, as the derivative of e to the x is simply e to the x. So what we need to do now is we have this equation y prime minus y is equal to x. So that's from the original differential equation. We can divide down both sides by e to the x, so we multiply with 1 over e to the x. So what we have here is y prime over e to the x minus y over e to the x. This is equal to x over e to the x. So we can rewrite this. Maybe it looks better to have e to the minus x times y prime minus e to the minus x times y. This is equal to x times e to the minus x. So what we see on the left side here is that this is simply the derivative of e to the minus x times y. So we can write that this is the derivative of e to the minus x times y. So if we simply use the product rule, we can see that this will be equal to this. And this we can just leave as it is. And what we can do now is integrate both sides with respect to x. Then this derivative will disappear. And what we will be left with, if we continue up here, is that e to the minus x times y is equal to the integral of x times e to the minus x dx. So we need to do integration by parts here. So again, there are several methods we can do that. What I like to do is write up this di method, where we make this little table here, and we decide what we want to take the derivative of. Well, I want to take the derivative of x because then it will very nicely disappear, and that means I will have to integrate e to the minus x. So the derivative of x is 1, derivative of 1 is 0, so we are done. And then the integral of e to the minus x is minus e to the minus x, and the integral of that again is going to be e to the minus x. And what I need to do now is cross multiply like this, and that will give me the integral. So this will simply be minus x times e to the minus x minus e to the minus x plus constant c. So what I could do now is find the value of this constant. So when x is equal to 0, y is equal to 2. So e to the 0 is 1. So if we plug in here, we'll have y is equal to, this becomes 0. And then minus e to the 0 is 1, so minus 1 plus c. And again, y is 2, so we can already plug that in here. So we see that c has to be equal to 3. So we are almost done now. We can rewrite the equation again. So we have y over e to the x. This is equal to minus x over e to the x minus 1 over e to the x plus 3. And well, what we can do now is multiply everything by e to the x to solve for y, as the question asks us to give this answer in y equals f of x form. So y will be equal to minus x minus 1 plus 3 times e to the x. And that is the solution to this differential equation.